I'm just getting over a sickness, so that's why my voice sounds weird. In the last lesson, we discussed the anatomy of an airplane, specifically a Cessna 172 and the basic parts of the plane, as well as how they function and what they control. But if you remember, there were 18 parts I wanted you to be familiar with, and we only discussed 9 of them. So today we're going to talk about the other 9, and at the end, we'll review all 18 parts as well as some real-world applications. Alright, let's pick up where we left off and start with number 10. Number 10 is the plane's wing. There's obviously one on the left and right side. The front of the wing is called the leading edge, and the back is called the trailing edge. The wing's job is to create lift, which, as we discussed before, is an upward force that counteracts gravity and keeps the plane in the air. This occurs due to 2 concepts, which are Bernoulli's principle and Newton's third law of motion. Feel free to Google these if you want to work ahead. Just know the FAA does not provide any extra credit. We'll discuss these in depth in our series of lessons on aerodynamics down the road. The bottom line here is that the plane's wings function to create lift. Next we have the flaps. Flaps are movable panels on the trailing edge of the wings. Pilots can extend or retract them in stages using a switch in the cockpit like this one. When the pilot extends or deploys the flaps, this just means that he or she uses the controls to hinge the flaps downward. This adds more curvature or camber to the wings and therefore increases drag. Picture it this way. Extending the flaps makes the wing more curved. As a result, air is pushed downward. This results in somewhat of a disruption of fluid airflow, causing the plane to slow down but also lift up more. So how do pilots use these? Well, they're very handy during takeoff and especially landing. Flaps are mainly useful upon takeoff if the plane is taking off from a shorter runway. If the runway is not very long, the pilot is going to want as much time as possible to get airborne because he has less room to work with. Deploying the flaps slightly allows the pilot to lift off at a slower speed, ensuring a safe takeoff. In landing, pilots usually deploy the flaps as they get closer to final approach. As they get closer to landing the plane, their goal is to slow down, not speed up. Makes sense. Well, the more the flaps are extended, the more drag the plane is going to have, and the slower it is going to go. This allows the pilot to fly slowly without stalling, descend steeply, and touch down at a safer, lower airspeed. Okay, that was a lot, but the bottom line for flaps is that they increase drag and increase lift when extended. Remember that. Flaps increase drag and increase lift when extended. Number 12. If you look right beside the flaps, you'll see another set of movable panels. These are called the ailerons. They too reside on the trailing edge of the wing, and their job is to control the movement of roll, which again is the circular tilt or rotation of an airplane. When a pilot wants to bank the airplane to turn, they move the yoke right or left. That movement makes the ailerons move in opposite directions. If the left aileron goes up, the right aileron goes down and the airplane rolls left. If the right aileron goes up, the left aileron goes down and the airplane rolls right. This works due to the same concept as the flaps. In fact, think of it as using a flap only on one side of the airplane. Lowering one aileron increases the curvature of that wing. And just like the flaps increase lift once extended, the lowered aileron increases lift on only the side of the plane it is on. If only one side of the plane is being lifted, it's naturally going to be turned to the opposite direction. Ailerons take advantage of this concept, and that is how they roll or bank the plane. The next one requires a little less explanation. If you remember from our last video, we discussed the fuselage and how it acts as the central body of the plane. Well, if you look past the fuselage, you'll find the tail of the plane, and this is called the empennage. All you need to know about this is that its main job is stability and control. Basically, it keeps the airplane flying straight and behaving itself. The empennage is home to the plane's main 2 stabilizers, which we'll discuss next. Alright, for 14 and 15, as I just said, we have the aircraft's 2 main stabilizers. For number 14, you can see a large appendage sticking straight up, almost like a shark fin. This whole structure here is known as the vertical stabilizer. The longer one, extending horizontally from either side of the empennage, is called the horizontal stabilizer. The vertical stabilizer provides directional stability, or keeps the airplane pointing straight ahead. If the air hits it from the side, it naturally wants to straighten out. The horizontal stabilizer provides longitudinal stability, or keeps the nose from wandering up and down. It's like a subtle counterbalance to the wings that ensures the plane doesn't try to flip out of control. Without these stabilizers, the airplane wouldn't be, well, stable. Pilots would constantly have to fight the controls, the plane wouldn't be able to self-correct, and essentially, flying would be terrifying. At least more so than it already is for some people. Now there's a lot of different tail configurations out there that might throw you for a loop, but if you look at each of these, you'll see that most of them have some sort of stabilizer, for the most part. Next is the rudder. The rudder is a movable surface on the vertical stabilizer. Think of it like the rudder on a boat, but working in air instead of water. The rudder controls the movement of yaw, which, remember, is the lateral rotation of an airplane along the vertical axis. Also, if you remember, the rudder is controlled by the rudder pedals, which are two pedals on the floor of the cockpit that resemble the gas and brake pedals on a car. While the top portions of these do function as brake pedals during taxiing, which we'll discuss more later, in the air they function more like a steering wheel for the rudder. When the pilot presses a rudder pedal, the rudder deflects into the airflow. This creates more air pressure on one side of the tail, pushing the tail sideways and swinging the nose in the opposite direction. Just think if the wings and ailerons are for leaning into a turn, the rudder is for keeping the airplane from sliding sideways while doing it. Number 17 is going to be the elevators. The elevators are movable surfaces on the horizontal stabilizer. Elevators control pitch, which again is the up and down movement of the airplane's nose along the lateral axis. Most airplanes are designed so the wings naturally try to pitch the nose down. The elevators counter this by pushing the tail down. For instance, if the pilot pulls back on the yoke, the elevators deflect upward. Elevators that are up create a downward force on the tail. Naturally, when the tail goes down, the nose rotates up. The inverse would be the case if you push the yoke forward instead. So just to make sure you're good on this, turning the yoke left or right will control the ailerons and therefore roll. Pushing the yoke forward or pulling it back will control the elevators and therefore pitch. Be sure you know the difference. Before we move on, I want you to also be aware of an alternative to the elevators, which is called a stabilator. Stabilators are not as common as elevators, but some planes do have them, so don't be caught off guard if you see one. You know how elevators are a portion of the horizontal stabilizer that hinges up or down? Well, the stabilator is identifiable by the entire horizontal stabilizer moving. In other words, the entire horizontal surface moves up or down. Again, they're not terribly common, but it's important to know the difference. The last one we'll discuss is number 18, which is the trim tab. Trim tabs are small, but they're crucial for comfortable piloting. A trim tab is a small adjustable surface attached to the trailing edge of the elevator. What it does is basically hold a control position for you, so you don't have to apply constant pressure. For example, say you're putting back pressure on the yoke, or just pulling it back, to keep the nose from pointing downward. Well, without trim, if you ease up on the back pressure, the nose will just quickly start pointing down. The trim tab, however, offers a remedy and keeps the controls rather straight so you can relax a bit. A trim tab is most commonly found on the horizontal stabilizer on the elevator, but on some planes they can be found on the rudder or the ailerons as well. The trim tab can be controlled and adjusted with a little black wheel that can usually be found to the right of the instrument panel close to the floor. To trim the nose upward, rotate the wheel downward and vice versa. It's backward, but it works. Alright, that sums up the basic anatomy that you need to be familiar with at this point in the game. Let's do a quick review of all 18. The cockpit is the control center of the aircraft where pilots operate, navigate, communicate, and manage all systems. The propeller is the set of rotating blades that produces thrust, each blade being attached to the propeller hub or spinner, which is the cone-shaped piece that connects the blades to the engine. The engine cowl is the outer covering that protects the engine and helps regulate engine temperature. The landing gear is divided into two categories, which is the nose landing gear and the main landing gear. These are necessary for taxiing, landing, and any ground operations, ensuring stability and controlled steering and stopping. The fuselage is the control point and body of the aircraft where the center of gravity is located. The antennas are small devices that allow the aircraft to send and receive radio signals and are crucial for communication. The struts are structural supports or arms that help hold the wings, landing gear, and other parts in place. The plane's wings are responsible for creating lift, and on the trailing edge of the wings are the flaps and the ailerons. The flaps are movable panels that extend or retract to increase drag and lift. The ailerons oversee the movement of roll and are responsible for banking the airplane. To control them, the pilot turns the yoke to the right or to the left. The empennage is the tail of the plane and is where the plane's two big stabilizers are located, which are the vertical stabilizer and the horizontal stabilizer. On the vertical stabilizer, we'll find the rudder, which controls the movement of yaw and is controlled by the rudder pedals in the cockpit. On the horizontal stabilizer, we find both the elevators and the trim tab. The elevators are movable surfaces that control the plane's pitch. Sometimes a stabilator is used instead, but they're less common. And finally, the trim tab is a small adjustable panel attached to the elevator that holds a control position for you so you don't have to apply constant pressure. Alright, here's a few questions to see if you were paying attention. While you're flying to a given destination, you realize you've strayed to the east of your heading. To correct this, you make a 20-degree bank to the west, rolling the plane leftward. What part of the plane is responsible for this movement? A. The rudder, B. Ailerons, C. Struts, or D. Vertical stabilizer? This one's going to be the ailerons. Remember, ailerons control the movement of roll, which is carried out during a banking turn. Number 2. After takeoff, you're wanting to maintain a steady climb up to 2,000 feet, so you pull back on the yoke. What part of the plane are you controlling when you do this? A. The flaps, B. Propeller, C. Rudder, or D. Elevators? It's the elevators, right? You push and pull on the yoke in order to control the airplane's pitch, which is dictated by the elevators. Alright, last one here. Number 3, you're trying to maintain an airspeed of 65 knots, but the nose wants to keep pitching downward, increasing your airspeed. As a result, you have to continuously pull the yoke back to stay straight. What part of the plane can you use to remedy this problem? A. Stabilator, B. Ailerons, C. Trim tab, or D. Landing gear? The answer is trim tab. If you said landing gear, I'm going to jump through the screen and kick you. Remember, the trim tab's purpose is to hold a control position so you don't have to apply constant pressure on the yoke. Okay, that is the basic anatomy of an airplane. I'd encourage you to watch part 1 and 2 of this multiple times before you move on, because these parts are going to come up several times throughout the course of these lessons. The more familiar you are with these now, the more fluid you'll be able to grasp concepts later on. Study up, and if you have any questions, feel free to comment or reach out.